So, moving into lesson 3.3, for those of you doing the notes with us, we are going to be working with functions today. So, a relation that for sure is a function. What makes a relation a function again? What's the definition for a function that we need to make sure we know? You have to understand what makes a relation, a set of ordered pairs, a function. Okay?
Each x value has a different y value.
Doesn't necessarily have to be a different y value. That's not the reasoning quite. Each x value has to have only one y value. Each x value has to have only one y value. In other words, each member of the domain can only be paired with one member of the range. Maybe that's the way to say it. Each member of the domain can only be paired with one member of the range. So when we're talking about our relations being functions, we have to keep that in mind, and we have to be able to state that, okay? So an algebraic expression that defines a function, we know what an algebraic expression is, right? What's an algebraic expression? That's from early in the year. What's an algebraic expression? Does an expression have an equal sign in it? No. What can it be made up of? Letters and numbers. It has to have letters, doesn't it? Otherwise it can't be called algebraic. It's called numeric if it doesn't have letters. So numbers, letters, what else? Operations. Yeah. But it can't have what? An equal sign if it's called an expression. So an algebraic expression that defines a function is a function rule. So we talk about there being a function rule for each function. When we input a value into that function rule, the input of the function is the independent variable. And is used in the function rule. So your independent variable is going to be in that, it's going to be the letter that is being used. It's going to be the variable that is being used in that algebraic expression known as the function rule. And I want you just to circle this. It is often x. Most typically, the independent variable is x. It can have other names though. We can be talking about an a and a b in a function, and then we don't have an x. So we have to decide which of those would be the independent variable. But whenever we're talking about x and y, which is the most typical, the x is the independent variable. So after you put in something for the x value, the independent variable, you will get an output. And that output of the function is the dependent variable. And this is what is usually the function rule is set equal to the dependent variable. It's the output, it is the result. After you use the function rule, after you input an x value into the function rule, it has an output, and that output is what your function rule is set equal to. And it is often y. Again, let's circle that. It is often y. Again, if we had the variables m and n being used in a function, we couldn't say that the dependent variable is y because y's are not being used. We have to figure out, is it the m or is it the n? And then a method of writing functions that is commonly used is function notation. Function notation. So we have to understand this because in fact, in most of your upper level math classes, that's how they will write a function, as a function written in function notation. So when we have it written in function notation, instead of it being set equal to y, the dependent variable, in place of the y, they use this right here, f parentheses x. Well, we got to know how to say that. It isn't f parentheses x, it is read as f of x. So in other words, we're going to evaluate this function for the x value, and then we'll be able to say what the function is equal to. So F names the function, and the x value is what are you going to put in. Okay, so let's start practicing what we would do in some of our homework that you have in your requirements today. Number one, we have this table of values, we have this relation. How many ordered pairs are there? 4, okay? We have to figure out what you would do to the x value, because remember the x value is the independent. I like to think of it like this. When you're feeling independent, you don't want anybody to make decisions for you. You're going to make them. You're in control. When you're dependent, that means you're counting on somebody, your parents or somebody, and whatever they say, that's going to be the result. It doesn't get to be you. So the independent variable, the x, gets to be in control and says, what are you going to do to me so that there will be a result, y, a dependent variable. So we're going to look at that table and say, what's happening, what relationship is there between the x's and the y's? To get from 1, when x is 1, remember that's the input. To get from x is 1 to y is 4. To get from x is 2 to y is 5. To get from x is 3 to y is 6. To get from x is 4 to y is 7. What's actually happening here? Andrew?
Yeah, added 3.
Added 3 to what? Be specific. If you add 3, finish it up for her, Devin. Or him, finish it up for him.
Add 3 to x.
Okay, if you add 3 to x, you get y. If you add 3 to x, you get the y. So we just stated our function rule. If you add 3 to x, there's our function rule right there. So how would we write that as an equation then? X plus 3. Here's our function rule, x plus 3. Algebraic expression with the input variable involved in it. And then we set it equal to our output, our dependent variable, which is y. So if we were asked to extend that table, we would be able to do it. We would just pick other values for x, substitute them in, input them, and we would get our output, our y value. Anybody have questions about that? Okay. Typically, we would see it written with the y coming first, like this. That's how we would typically see it. Y equals the dependent variable equals the function rule. And function notation, if we have to write it in function notation, we're saying the function is evaluated for an x value is equal to your x value plus 3. So what really just happened there? What do we do to write it in function notation?
Just change the y to the f of x.
Yeah, we just changed the y to f of x. So you need to be able to think of y and f of x as the same thing. They really mean the same thing. So if they ask you to write it in function notation, they're just asking you to replace the y value or the dependent variable, whatever it is, with f of x or f of the independent variable, whatever the independent variable is. Questions, anyone, on that problem? Okay, let's do number 2 then. Sometimes it's easier to write these in a table so that you can see the relationship better. So it might be worth taking the time to do this. When x is 1, y is 1. When x is 2, y is 3. When x is 3, y is 5. When x is 4, y is 7. So that we can figure out the function rule. So who thinks they got the function rule this time? Austin.
What I'd like starts surprising me adds more, so the first one adds 0 equal to x, and the second one adds 1 and 2, so 3.
Okay, but we can only write one function rule. So right now you're kind of giving me a whole bunch of function rules. You're saying x plus 0, and then you're saying x plus 1, and then x plus 2, right? And then x plus. But we can't. We only have one function rule, so we're gonna have to figure out a rule that would, if we do something to the x value, it will produce that y value. You don't have to just add and subtract, by the way. You can multiply, divide.
Multiply by 2 and subtract.
Okay, he says multiply the x value by 2 and subtract 1. So let's check that out. X times 2, or 1 times 2 is? Take away 1 is? 1, our y value. X times, or 2 times 2 is? 4, take away 1 is? 2 times 3 is? 6, take away 1 is? Gotta make sure it works for the whole table. I know that you're like, why are you doing this? Because all of a sudden the behavior can change. 2 times 4 is?
8,
Take away 1 is?
7,
Oh, it seems to work though for that whole set of ordered pairs, doesn't it? So if you multiply x by 2 and subtract 1, you get y. So the multiplying the x by 2 and subtracting 1 is the function rule, and we would set that equal to the y. So what would our equation be?
y equals x plus 2 minus 1.
Y equals what?
X plus 2, or x times 2 minus 1.
Okay, so what's the shortest way that algebra would write x times 2?
Oh, x.
2x.
2x, yep, 2x minus that 1. Yep, there's our function rule set equal to y. The function rule is the 2x minus 1 set equal to our dependent variable y. Well, how would we write it in function notation then? F of x is equal to 2x minus 1. So just pay really close attention in your homework if they ask you to write it in function notation. Make sure that you use f of x instead of y, okay? So questions. So again, you're gonna have to figure out the function rule, and it has to work for all of the ordered pairs. You can't just make sure it works for the first 2, because that can break down later on in the set. You have to make sure it works for the whole set of ordered pairs in the function. Okay, so no questions. Okay, then we'll move on to independent and dependent variable, being able to identify them. So identifying independent and dependent variables. Students have a fair amount of trouble with this. So let's make sure we understand. Independent is the one in control. Dependent is the result. Independent gets to say, here's I'm gonna tell you what's gonna happen, and here dependent says, okay, fine, and here's what I am because of you. Okay, so we have to think in the situation, which of the two things in the relationship would be in the control. Okay, so a doctor needs to know your weight before determining the amount of medication. So what do you think we could say in that situation? Now, we're not writing an equation or anything. We are right now just practicing saying what's in control here and what would be the result because of it. So AJ, what do you think is?
The independent variable would be the weight.
Okay.
You can change the weight by adding or subtracting. The dependent variable would be the amount of it.
Yeah. So the independent is the doctor. Why do you suppose they weigh you at the doctor when you go? They need to know how much you weigh. So if they're going to prescribe some medicine, they can say, oh, they should get this dosage of medicine. So the independent is the weight, and the dependent is the amount of medication. A 2-year-old put on amoxicillin does not get the same dosage as a freshman in high school gets. Because, why?
Because they're smaller, so they can't take as much.
Yeah, you have different body weights, and so your bodies are going to handle it differently. Okay. Number 2, a company charges $10 per hour to rent a jackhammer. What's in control here, and what would be the result because of that? So the amount of time, what?
If the time goes up, the price goes up.
Okay, so we can even be more specific than that, though. What's the time measured in?
Hours.
Hours. So independent is the hours, and dependent is the, don't say just cost, though, because there's already a cost involved in this. the total cost, right? It would be the total cost, or I don't even know if we could want to just say cost to rent, because the $10 per hour also represents a cost. So we might probably want to say it as total cost. If you rent this jackhammer for 5 hours, it's going to cost you how much? $50. The total cost would be $50. Okay, so there we're not writing any equations. We're just practicing being able to identify the independent and the dependent so we can write equations. Okay, so now we're going to practice that. Identify the independent and dependent variables. Write an equation in function notation, which means what again? How does function notation look? F of x. For each situation. So a math tutor charges $35 per hour.
Independence going to time, so hours.
Okay, so independent is going to be the hours, number of hours. We're going to be a little more specific this time because we're going to write an equation. Number of hours. You get to decide how many hours you're going to be tutored. What's the dependent, Josh?
How many dollars total?
Yeah, total cost. Yep, total cost. Total cost. And that would be in dollars, of course, right? Okay? And what would the equation then be then? How would we determine
Y, f of x is equal to 35x.
f of x, the dependent variable? Remember, f of x is the same as y. So f of x is equal to 35x because you have to take $35 times however many hours you're going to hire the math tutor for. So if you're going to have the math tutor for 10 hours, 1 month, it's going to cost you
$350.
f of x would be $350. And basically what we would say then, we would say f of 10, we put a 10 in there for x, we'd say f, the function evaluated at 10 would be equal to 35 times 10, and you just told me that f of 10 would be $350, right?
Yes.
Okay, let's do another one. Number 4, a fitness center charges a $100 membership fee plus $40 per month. What's the independent, what's the dependent in this one?
The amount of months that you have.
So the number of months, okay. Number of months is the what? Independent, because you get to determine that, don't you? You get to decide that. How many months are you going to purchase this membership for? And the dependent would be
Total cost.
total cost. Now, oftentimes it is total cost, but don't get, in the habit of thinking every time the dependent variable is going to be total cost. Just so happens that all of these problems had to do with something where the output would be total cost. Okay, write an equation on your notes right now. Write an equation for that in function notation. Okay, and since it's Andrew's birthday today, we'll let him share with us.
F of x is equal to 100 plus 40x.
You guys agree with that? Okay. What's that 100 plus 40x called again? The function rule. That is the function rule for this function. Multiply your x value times 40 and then add 100. And you will have your output, your dependent variable, what the function is equal to for that particular situation. Okay, and one last thing we're going to answer here. Does f of x represent domain or range? What do you think, Devin?
Oh, it's the range.
Why? Why is it the range?
Well, because f of x is y.
Okay, so range, it is, we're going to say it's the range. F of x is the y value, and we know that the range is made up of y values, don't we? So if we are given the range values, the y values as f of x values, we should still be able to identify the range. If there isn't a y in the table, so in other words, I'm saying something like this. If we had a table that looked like this, and it was filled out, and you were supposed to give the domain and the range, you would give the domain by looking at the x values, and you would give the range by looking at the f of x values, yeah. Okay, any questions? Okay, then I'm done with you, now you can use the rest of the time to work on, you did this counts as one of your 4, you have 3 others to complete for tomorrow.